to package all of the necessary drivers, a network stack, etc., into a library, a statically compiled library that you can then link to. So it turns your service into an ELF binary, and we attach a bootloader in front of that, so that your service can pretty much boot on x86 hardware. So one other word for it is a unikernel. So that's a pretty new concept. I think it was coined in 2013 by Anil Madhavapedi and Richard Mortier. It's a unikernel is what they describe as a single address space virtual machine image, or a machine image that's created by a library operating system. So it's pretty much a single service operating system, and the key features are one, single address space, because that means you can you know that there will only be one process running inside of your operating system. That means you can massively reduce the complexity of that operating system. And the other really important feature is that it has to be created by a library operating system, so that you can avoid, you can bloat as much as you want. I mean, we can keep adding features to IncludeOS. And then that means that the IncludeOS library is going to grow. It can grow indefinitely, but once you build your service, it will do static linking towards that library, and essentially only what you actually use in your code is going to get included in. And that means you get the smallest possible, at least in a design perspective. That's kind of the slimmest way to design it, so that your program essentially becomes a virtual machine.
So you write your C++ program, then you compile it with the IncludeOS framework, and now you have a thing that can just boot on a virtual computer.
That's it. It's pretty cool.
I mean, it's almost too cool to believe in a way. So what is the actual bootstrapping process? What does the computer look like to your program once the booting is done, I guess, if you will?
Yeah, and that's going to, I hope that will be something you will enjoy, having seen that C++ 14 is now on the Commodore 64. I watched that cast and I thought it was just fantastic. So what we're doing is exactly the same as when you booted a normal x86 computer back in the 90s or in the 80s. We see hardware exactly like exactly like the operating saw the hardware back in when the first IBM